Hello, in this lecture, we are going to continue with the question that we've led from previous lecture. We were discussing that instead of potential, if we are supplied with some initial conditions in terms of like surface charge density, what to do? So I hope a few questions we'll also do from previous year questions also, so that you should get an idea of what is being asked in examination also. So we wanted to find potential inside as well as outside. The sigma naught is known as k cos theta. And see, I've already stated my AL is in this format. So otherwise, you'll take a general approach. I mean, you take the same approach that I've taken, that also I'll do. But here I have already calculated AL, so I'll use my AL. Otherwise, we'll take a general approach. General approach मतलब समझ रहे हो? मतलब I'm not going to remember this expression. All I need to know is कि whenever I'm supplied with a sphere in azimuthal symmetry, and the problem is of azimuthal symmetry, and there are no charges inside as well as outside, then I will just use these two conditions. That is, potential must be continuous and normal component of electric field would suffer discontinuity. If this is and if there is a surface density which has been given to us, I'll solve these two equations every time. Like in the examination also, I'm going to do this. I'm not going to remember this entire thing. But since I've done it right now, so I will just use these conditions up, and then we'll solve the question with general approach as well. Don't worry. So if AL is given, I know my AL is given. So what I would do, I would simply use the orthogonality conditions of, I'll use the orthogonality condition of Legendre's polynomial. So what I would do, orthogonality condition for Legendre's polynomial is something that I'm going to do. Okay, so Legendre's polynomial की orthogonality condition use करेंगे. देखो कैसे. So AL is given by 1/2 epsilon r raised to power L minus 1, and then you have this 0 to pi sigma naught theta PL cos theta sin theta. So what I'm going to do is, see, since I already know this, so देखो, sigma naught theta, you just try to express in terms of Legendre's polynomial. So I'll write it as P1 cos theta. Is that clear? So I know that my
AL
sigma, हाँ बेटा बोलो.
sir k/3 epsilon naught RE AL
K
k/3
upon 3 epsilon naught. Right, right. But I'm just revising it for you. So होता क्या है, for example, I know that my AL is given by, I think this is 2 upon epsilon naught r raised to power L minus 1. This is something that I've derived, 0 to pi. And then you have the sigma naught theta, and then you have this PL cos theta d theta. From the structure of this sigma naught, you know that your sigma naught is P1 cos theta. So you know that except L equals to 1, all the ALs would be 0. Is that clear? L equal to 1 wala AL would give you something, but otherwise all AL would be 0. So you see, because why? Because sigma naught cos theta is P1 cos theta. So here if I place P1 cos theta, it will only give me a non-zero result if L is equal to 1. Otherwise, if L is not equal to 1, then AL would be, AL would be 0. Is that clear? Okay, so
yes
what
sir
all you need to do is you just need to find A1, and I think Bharat has solved it. So I'm going to straightway use it. So just A1, you just need to find, this will be like 0 to pi, and this will be cos theta whole square, and then there would be sine theta d theta, because P1 cos theta here and P1 cos theta here. And this is something that you can solve from standard 12th also. So this is like k upon 3 epsilon naught. I suppose you'll get. So A1, once you know that your A1 is this. So you can also know that your P1 would be A1 into R ki power 2L plus 1. So this will be like A1 into R cube. Is that clear? Since ALs are 0, except for L equal to 1, so BLs would be 0, uh, except for L equal to 1. Is that clear? So potential anywhere inside can be written as AL R raised to power L PL cos theta for L equals to 1, because only L equal to 1 survives. So this will be like K upon 3 epsilon naught, and then you have this R, and then you have this P1 cos theta, so this will be cos theta. So potential anywhere inside, you can write K upon 3 epsilon naught R cos theta. So for all R less than R, the potential is this way. And for all R greater than equal to R, that is potential anywhere outside, can be written as k upon 3 epsilon naught, and then you should have r cube, and then you should have r square cos theta. Is that clear?
Yes, sir.
Okay. Okay. So this is something that we've already done. Now, just do a problem in TFR which came, so that at least कुछ exam का question भी हो जाए. So we will be able to understand कि exam में क्या कैसे पूछा जाता है चीजों को. So I'm going to write one problem because I have not taken a snapshot of the same. So I'll write it in brief. So this is question from TFR examination, and it was asked in TFR 2017. Okay, and they wrote that consider a shell, a spherical shell of radius r such that potential on the surface is given by v. This was given as r, theta, and phi, and this r is like r equals to r. Okay, so is given by v naught cos square theta. This is something that we've done already, but since in TFI it was asked, so I'm just revising all the concepts so that you should understand what is the format of question that is asked. Where theta is shown in the figure means theta, they have shown that this is your theta. So they made a sphere and that showed that theta is with respect to the z-axis. Okay, this is theta. This is the center C. Okay, and this is your R. Like till this point, this is R. And there are no charges. There are no charges. Uh, then it is written what is the potential. What is the potential outside the shell? Outside the shell at P, which is 2r away from the center. So it is given that your spherical on the spherical shell you have this kind of potential, that is v naught cos square theta. And what is asked, that what is the potential outside the shell at P, which is at a distance 2r away from the center. You just try to find an answer for this. Meanwhile, I'll give you option. You just try to find the answer. Okay, so this was asked. You just try to solve this question, and I'm giving you a 2 minutes to 3 minutes.
भैया ऊपर फर्स्ट लाइन क्या लिखी, कंसीडर अ
spherical shell with a potential given on the surface. Okay, with a potential given on the surface v naught cos square theta. So like on the surface you can expect some charge density, but otherwise inside and outside there's no such charges present, so you can readily apply your Laplace's equation, and then you can simply find a potential outside. And once you can find potential outside, all you need to do that is at r equals 2 you have to place 2r. At r equals 2 you have to place 2r. and then you can find the solution. So I just wanted to make you understand that such questions are asked. This is the format of questions that are asked, and mostly you'll find this in TIFR or JEST or NET or something. Okay, so how to do this problem? I hope all you need to do is you have to just compare these two terms. Like your potential outside is given by R is BL R L plus 1 PL cos theta, and you have to compare this with P naught cos square theta. ठीक है, so इसको compare करते हैं. So what I'm going to do is at R equals to
L equal to 2 will survive.
हाँ L equal to 2 survive. बस वही देखते हैं अपन check करते हैं. Let us do. So let us do this problem. So start करते हैं B naught and then this will be P naught. So I think B naught upon R would be there. Then and then there would be some B1 upon R square. P2 cos theta is sorry, P1 cos theta is simply cos theta. Then you have this B2 upon R cube. This is 3 cos square theta minus 1 upon 2. Is that clear? And this is equals to V naught cos square theta. So all you know is that you will have a constant term and B1 would be 0 for sure. And here you can find that your B2 would be 2 V naught R cube upon 3. And once you know your B2, you can also know your B naught, because B naught would be equals to B2 upon 2R square. Is that clear? Because see, constant term would be 0. So you know your B naught also. B naught would be equals to what? B naught will be equals to 2. No, 2 bhi hat jayega. Then this will be simply B naught upon 3. And then there would be some R. Is that clear? I mean, this is fine. B naught and B2s are, we have found B naught and B2. So potential anywhere outside. So I'm writing it here. Potential anywhere outside, I can write it as B naught, V naught upon 3, and then there's some R here, and then there's a small r here, and you have P naught cos theta, that is simply 1, plus this would be like 2 V naught capital R cube upon 3, and this is, I think, R cube here, and then you have this V2, this is 3 cos square theta minus 1. Is that clear? Now all you need to find is that anywhere outside this is the potential. So why not place R equal to 2R? Because see, R equal to 2R also lies outside. And this is what is being asked. That what is the potential at point P, which is at a distance 2R from the center. You just place R equal to 2R here. So what you'll find, you'll simply find V naught upon 6. Because if I place 2R here, R gets cancelled. And then you have this, if you place 2R here also, so this will be like 8R cube divided by, sorry, जो भी है ये, I think this would be 8R cube नीचे, and then this would be 12, I think.
Yes.
हाँ बेटू बोलो.
सर ये बी नॉट आपने 0 क्यों नहीं लिया?
देखो इस वाले टर्म में भी तो है, लाइक हियर इज अ कांस्टेंट.
हाँ तो सर लेकिन राइट हैंड साइड में तो कोई भी कांस्टेंट टर्म नहीं है ना.
हाँ ठीक है, राइट हैंड साइड में कोई भी कांस्टेंट टर्म नहीं है, लेकिन लेफ्ट हैंड साइड में टोटल कांस्टेंट टर्म्स ये नहीं होंगी. दिस इज योर टोटल
ये
कांस्टेंट टर्म.
हाँ
ओके,
होगी
सो
सर.
यू हैव टू इक्वेट इट टू जीरो दिस. इसलिए मैं कह रहा हूँ जल्दीबाजी में ना यही
अच्छा.
गलतियां होती हैं, मोस्टली यही गलतियां
ओके
करते हैं,
ओके.
है ना. तो ये ध्यान रखना.
ओके
इसलिए
सर.
मैं कह रहा था कि तुम अभी तसल्ली के लिए क्या करो, इवन टिल 5 टर्म्स भी खोल के देखो. जैसे कभी क्यूब आता है ना, तो यू नो दैट P5 के अंदर भी क्यूबिक टर्म आ जाता है. यू एक्सपैंड टिल
यस सर.
5 ऑल्सो, सो दैट होता क्या है कि मतलब कोई कंफ्यूजन नहीं रहना चाहिए.
जी
बिकॉज
जी
आई
सर
तो
जी.
नो द solution to problem, so I may expand till the desired. But since you are in the practice round, do all those things. अच्छा, अभी क्या करेंगे? I'll place at small r 2r also, so that will be like 8r cube. 2 will get cancelled. 4 12. So this will be like v naught upon 12 here. R cube will get cancelled. Is that clear? V naught by 12, and then there will be, I think, 3 cos square theta by 2, and then that will be minus 1 by 2. So overall, I think this will be V0 by 12, V0 by 6 minus V0 by 24. Is that clear? कुछ गलती तो नहीं कर रहे ना, कोई जल्दीबाजी में गलती की, then there would be a problem. 2 r अगर if I place here, it will be 8 r cube get cancelled, 2 से 8 4 12 V0 by 12. ठीक है. So
सही है।
overall है ना, यही आएगा. So this will be like V0 and this is 1 by 6 minus 1 by 24. So if I take 1 by 6 common out, so this will be like 1 minus 1 by 4. So this will be like 3 by 4 here. And then there would be some V0 upon, like this is 4 and this is 8, V0 by 8 cos square theta. Is that clear? And this is V0 by 8 also. So overall you will get, I think, V0 by 8 and then there will be 1 plus cos square theta. Is that clear? So this is like, these are the questions that are asked in TIFR examination. Well, mostly you will find these questions in TIFR only. And I want you people to get selected in TIFR only. Like, they are the best institute when it comes to research, ISC and TIFR. So if you can make your place there, so they are going to ask you these questions. So I think answer A, answer should be A. Is that clear?
Yes, sir.
Okay. Another question I have discussed, but I think I did not record that lecture. So I'm just giving you so that you just attempt it all over again. So, because today we are at a lack of topic, because either I'll start the topic and I'll have to leave it in middle. So let us do some questions instead. So again, this was asked in TFR. It was asked that there were given 5 sides of the cube. So 5 sides of cube were given to you. And this is something that I've already discussed, but again, because since that was not recorded. So 5 sides of the cube were given. Okay. And this is a metallic cube. Metallic cube was given to you. And 5 sides were given. And five sides were grounded. 5 sides were grounded. 5 sides were grounded. So all the 5 sides were grounded. Sorry, all the 5 sides were grounded. Grounded. Sorry, yeah. 5 sides. So the 5 sides were grounded, and this side was maintained at potential 5. This side was maintained at potential 5. It was asked what is the potential at the center. So it was asked what is the potential at the center. So how would you find? You know that at the center, sorry, at the center. So how would you do this question? You know that I have already taught you by mean value theorem. You know that we were doing that. If I have to find the potential at point x comma y, all I need to do is I need to go in the neighborhood. And if it is a continuous case, then I would simply integrate my v dl divided by integral dl. This will give me the average of the potential all over, and this average potential is equal to the potential at the center. Similarly, when I'm going to do 3-dimensional case, if I have to find potential at some r vector, then what I'll do, I'll simply make a spherical surface all over. I will try to find the average potential over the surface by using this formulation. And this average potential is equal to the potential at the center. So these are the mean value property which are applicable for the harmonic function. And similarly for the discretized case, what you're going to do for the discretized case, all you are given all the 5 sides to have potential 0. So you can simply take summation I equals to 1 to 6 potential VI's. AI's are the area of the area of the faces divided by summation AI's. And let's say if the side is A, so what will be the denominator? Denominator will be simply 6a square. And what would be the numerator? Numerator will be on the 5 sides you have 0 potential. On the last side you have potential is like 5 into a square. So this gets cancelled, so this will be like 5 upon 6. Is that clear? I hope it is clear. है ना, कर लोगे? चलो equation तुम करके बताओ फटाफट से. This was asked in JEST examination, so try to do this question. Okay, so question was a cube. So I'm not going to write the option, you just dictate the answer. I think till the time I'll write, you will give the answer. A cube has a constant potential V on its surface. If there are no charges inside, if there are no charges inside the cube, what is the potential at the center of the cube? What is the potential at the center of the cube. So this was asked in JEST. So cube has potential V on its surface, implies on all the faces the potential is given to be V. And if there are no charges inside the cube, what is the potential at the center of the cube? सोचो सोचो फटाफट.
6V.
नहीं 6 divided by 6 again. See, है ना? So you have like you know that your cube has potential V on its surface, मतलब on all the sides, है ना? तो तुम्हारा आंसर होना चाहिए I think B, है ना? तो देखो आपके हर साइड पे पोटेंशियल कितना दे रखा है? V दे रखा है. So potential on all the sides is given a V. So V into 6A square. Sorry, मतलब 6 into like this and divided by 6A square. So A square gets cancelled. Answer should be V. Is that clear? मतलब ऐसे क्वेश्चन में जल्दीबाजी मत कर देना क्योंकि b/6 again is given as an option. ठीक है, तो ऑप्शन नंबर डी, if you see this was asked in JEST 2012. Okay, so जल्दीबाजी मत करना. So this is B and this is I think 5/6. होता क्या है at times when you are supplied with such question, अगर तुम्हें पता ही नहीं है कि ये, तुम सोचोगे यार कैसे निकाले potential at the center, so then you will not be able to do. If you know the Laplace's equation and you know the mean value property, then it is fine. Then it is fine. So this is what we do in mathematics and physics. We develop a generalized result for a very complicated case. Then for whatsoever case it would come, if the conditions are resembling, use the property or use the theorem or probably use the result that you have developed for the more complicated case and just use them. So I'll do a question on like charge density also. I'm just giving you a simple question. So this was asked in GATE examination. Okay, so question was asked that a spherical conductor is placed in external electric field given by E naught K cap. E naught K cap. Okay, E naught K cap. So I'm drawing a diagram. So this was how it was given in the exam. Okay, so this is how it was given in the exam. So here, from here, theta was given from here to here. Theta was given from here to here. And this was your K cap. K cap means Z axis ऐसा बता रखी है. Radial direction से again angle is theta only. So this is how it was given. You were asked what is the charge density? What is the charge density on the sphere? What is the charge density on the sphere at theta equals to 30 degrees? So this was what was asked in your examination GATE. So again, a simple question. I told you that when I was teaching you this electric field thing, so whenever your spherical conductor is placed in electric field, then the charge density on the surface is given by 3 epsilon naught E naught cosine theta, if you remember. I mean, we've developed this result. So at least remember this result, because at times certain things can be asked in the examination, which may require the remembrance of the result. At least in GATE examination, they expect you to remember this result. And this is a very, very, very standard problem. Like this is very standard problem. So I expect you to remember this result at least. इसको remember करने में I don't think there is an issue. So you know that your induced distribution is 3 epsilon naught E naught. And this is what is being asked there in the examination. They're asking that what would be the surface density at theta equals to what was given 30 degrees. All you need to use is this formula and you are done. You just find me the
सर जो
answer.
हमने ये फॉर्मूला डिराइव किया था इसमें हमने एक्सटर्नल इलेक्ट्रिक फील्ड कंसीडर की थी क्या?
हाँ बिल्कुल बिल्कुल एक्सटर्नल इलेक्ट्रिक फील्ड कंसीडर की थी. यू जस्ट रिमेंबर. काम क्या है, सॉरी ऊपर क्या देखो. अगेन मैं वापस ऊपर ले जाता हूँ सो दैट यू रिमेंबर. टाटा टाटा. दिस इज अ डिफिकल्ट थिंग टू डू विदाउट एक मिनट माउस को ले आते हैं.
फिर हम
मैं ला रहा हूँ. एक मिनट एक मिनट
कंसीडर की थी.
एक मिनट. ये देखो हियर इट
हमारे
इज.
पास एक लगेगा.
ये देखो दिस इज हाउ इट वाज. याद करो. कंडक्टिंग स्फीयर प्लेस इन एक्सटर्नल इलेक्ट्रिक फील्ड ई नॉट के क्या ये किया था. And when we were solving all these things, and when we came to finding the induced distribution, here it was.
Yes sir, yes sir.
Okay, here it is. Actually, there is a problem with mouse. So, so this particular result we developed for the if electric field is present along the k cap direction. बस किया क्या है? तो डायग्राम को इस तरीके से बनाया कि बच्चा कंफ्यूज हो जाए एग्जाम. So what they've done, they have placed your k cap along x axis. मतलब traditionally what you take x axis, they have placed that k cap there. Is that clear? Or
Yes
is
sir,
that
clear sir.
है ना? तो कंफ्यूज मत होना. Secondly, for if you're preparing for examination, I would suggest कि even if I have done long derivations, make some short notes where you just write these formulas and like होता है ना, मतलब आप सिंपली लिखेंगे इलेक्ट्रिक फील्ड E नॉट के कैप में है, देन द सरफेस डेंसिटी इज दिस, चार्ज इज दिस, इलेक्ट्रिक फील्ड का आंसर ये होता है. सो दैट मतलब होता है क्या कि कभी कभी डायरेक्ट एग्जाम एंड I can in the examination, phi was given. Like in this particular examination, when this question was asked, potential was given to you. So even if you don't know, you can find from the boundary condition that you're like for example, in this question itself, phi was given to you. Like even if you don't know phi, it was given to you. So minus E naught R cos theta plus E naught A cap upon r square, and cos theta was given to you, and this particular radius for the sphere was given as a. So this is all what was given to you. So if in case you forget this result 3 epsilon naught e naught cos theta, what you can do, since potential is given to be this,
Electric
you
field
apply
we can find.
simply. आप एक काम करो, डेरिवेटिव पता करो आउटसाइड, डेरिवेटिव पता करो इनसाइड एट r इक्वल्स टू a. आप क्या करोगे, ऐसा कुछ करोगे, माइनस डेरिवेटिव at r equals to a minus, and you know that this is equal to what? This is equal to minus sigma upon epsilon. Is that clear? Because this will be minus here. So I've taken that minus all over and I've placed it here. Electric field outside minus electric field inside suffers a discontinuity of sigma upon epsilon. Electric field outside radially it will be this. Are you getting my point? You can use this expression and then also you can find. So exam में ऐसा नहीं होना चाहिए कि just because तुम्हें याद नहीं आ रहा, you are leaving that question. Don't do that. थोड़ा थोड़ा तो आइडिया है ये कि potential if I am given, I know that my electric field suffers a discontinuity if my surface contains sigma, then electric field outside minus electric field inside, I will just differentiate it, place r equal to n, then I can also find sigma. मतलब अगर एग्जाम में फॉर्मूला याद ना रहता हो, एंड इफ एट ऑल एग्जाम में याद रह जाता तो क्या, जिंदाबाद. 3 एप्सिलॉन नॉट ई नॉट cos theta, place theta equal to 30 degree. So 30 degree कितना होता है? I think this is root 3 by 2, right? Cos 30 is root 3 by 2. So 3 root 3 by 2, epsilon naught E naught is the answer. Okay. Is that clear? Or is that not clear? समझ में है
सर
नहीं है?
फाइव में, सर ये जो फाइव जो क्वेश्चन में गिवन था इसमें कॉस दूसरी वाली टर्म क्या लिखी हुई है आपने?
ये वाला बोल रहे हो?
हाँ जी, इसमें कॉस क्या
E
लिखा
naught
हुआ
A
है?
cube
कॉस,
upon R square cos theta.
कॉस थीटा, ठीक है सर.
No, this is what I was supplied in the question. Okay. So अगर मान लो नहीं भी आता है, then you can try your base. You can go from basics and then you can do all those things. Is that clear?
Yes.
So I hope till now we have done everything. No? Now, one case that remains to be discussed is when you are not supplied with this azimuthal symmetry, then what to do? Okay, then what to do? So I'm going to just write a general result today, and we're going to discuss this problem tomorrow. But still, I'm just going to write the results. So, for example, now if you're not supplied with azimuthal symmetry, so this is थोड़ा सा difficult case. I don't expect this to be coming in examination anyway, but still, if it comes, I'm going to write a general result. So I'm writing complete solution of Laplace's equation, complete solution of Laplace's equation in spherical polar coordinates. That is, now you do not have this azimuthal symmetry. So I'm going to write complete solution in spherical polar coordinates. And this is something that you'll find in your hydrogen atom also. Okay, the almost similar things, because after all, what is there? वहां पर भी तो एक तरीके की आप डेल स्क्वायर मतलब डेल स्क्वायर साई अपॉन डेल आर स्क्वायर प्लस इसी तरीके का तो प्रॉब्लम वहां भी सॉल्व कर रहे हो. सो वहां पर भी एक लैप्लेजियन इक्वेशन टाइप की ही इक्वेशन आप सॉल्व कर रहे हो इन स्फेरिकल पोलर कोऑर्डिनेट्स. Okay, so we'll do all those things. So complete solution of Laplace's equation, or you can say without azimuthal symmetry. I'm concerned with without azimuthal symmetry. So if I'm not using my azimuthal symmetry, now my e raised to power e की power iota m phi term will also come. E raised to power iota m phi terms will come. Okay, so now the solution is given by, I'm writing directly the solution, v, r, theta, and phi are given by, now you will have this radial term, absolutely fine. Al, r raised to power L, BL upon R raised to power L plus 1. This was clear. This will exist. Now, instead of PL, you will have associated Legendre's polynomial. If you remember, I told you in the very first day that the general solution comprises both L and M terms. But if there is an azimuthal symmetry, then M is dropped. Because if azimuthal symmetry is there, then M should be equal to 0, and then you will simply have PL cos theta. So if you do not, if you are writing an expression for the entire thing, like entire thing means if you are not considering the azimuthal symmetry, like if you are not considering that a problem is phi symmetric or symmetric with respect to phi axis, then this term will come. And additionally, you will have this kind of term, Cm e की power iota m phi plus some, you can say dm e की power iota minus m phi. So this is how you're going to write the solution. Now, this will be too difficult thing for you. So what people do, what is done, this is compactified into a form which is called as spherical harmonics. This is compactified into something called as spherical harmonics. Okay, we write the entire product in something called as spherical harmonics. And again, spherical harmonics are orthogonal to each other. The orthogonality relation I'm soon going to write. So what you can do, you can expand, if certain potential is given, you can expand that potential in terms of like linear combinations of spherical harmonics, and then you can compare and do the problem like the way you were doing. The only thing is you'll have to remember some spherical harmonics. And why I'm telling you to remember spherical harmonics, because the same problem, almost similar kind of problem, you're going to face in your hydrogen atom also. So if you remember here, so there would be less burden on you when it comes to hydrogen atom. So this particular product expression is then referred to as spherical harmonics, denoted by YLM, and sometimes people write L here, M here. So whatever suits you, theta and phi. Okay, is that clear? And this particular YLM is also an orthogonal function, and the orthogonality is given by integral 0 to pi d phi, integration 0 to pi, and then you have this YLM. So एक साथ ही लिख लेते हैं, YLM theta phi, and then you have this by LM star. We are going to do a few problems on this tomorrow, but I just wanted to write this expression so that at least we started from here. Sine theta, d theta, d phi, and this is equals to chronicle delta LL dash, chronicle delta MM dash. And in general, this YLM, all these things, don't worry. I'm just writing because तुम्हारे notes सही बने, but all these things you're not, in general, are not required. But still, if you want to write it up, so I'm just giving you. This is given by 2L plus 1, and then you have this term like L minus M factorial, and then you have this division by L plus M factorial, and then you have this term called as 4 pi here, and then I think there will be term PL m cos theta, and then there will be some e की power iota m phi. So all these things I've written. Don't worry, you don't have to memorize all these things, but overall understand that instead of, if you do not have this kind of azimuthal symmetry, then these terms will turn up, and this no longer remains a Legendre polynomial. Rather, the differential equation will serve you a solution which is called as associated Legendre differential equation. If you go back and see that lecture, I have written PLM, and then I used I mean, I have not done the complete solution because, again, I told you this is a very, very big derivation that I refrained because of the time also. And I believe that you can do this on your own from the books. So overall, this particular thing forms something called as spherical harmonics. And the spherical harmonics are orthogonal to each other. The orthogonality relation is given by this. And then in general, this is the expression. So why I have written this? Because at times in your university examination, some PhD entrances, or probably in some lectureship examination, this is asked as it is. Like I don't know why, but they want you to memorize this. So I've written it so that any such similarity if you find, you can do that particular thing as well. Okay, so overall, uh, I would list some of the spherical harmonics, so that it helps you. And all the other discussions we are going to do tomorrow, at least you should remember y00. Y00 is simply 1 upon root over 4 pi. You can remember y, you should remember y11. That is, this is negative root over 3 upon 8 pi. Even if you forget this, like all these things, at least remember what remains. So you know that if I'm writing 1 here, so your m would have 1. So simply m would have 1 here. Okay. And if I'm writing 1, 0, it will be, I think there would be no such term in phi here. So at least this is easier to remember. And y1, sorry, y22 लिख लो एक बार. Y22 is given by, I think it is 1 over 4. Uh, and don't worry, everybody memorizes this, that there are tables for this. So like ऐसा कुछ नहीं है कि being a physicist you should remember it. I don't believe कि anybody memorizes all these things, but still, because you are preparing for an examination, so that is why I'm insisting you at least have some sort of अंडरस्टैंडिंग कि देखो, अगर m इक्वल टू 1 होगा तो e की पावर आयोटा m आएगी, m इक्वल टू 2 होगा तो e की पावर आयोटा 2 आएगी. If L and M's are there, then you don't have you don't have cos theta, rather you have sin theta. Just keep these patterns in your mind, and I hope this once you have these patterns in your mind, instantly you're going to you're able to recognize. Okay, so last I'm writing y20, and that is it. I mean, इससे ज़्यादा I have, and I'm telling you, I have never memorized all these things. I only know them by patterns. Patterns समझ पा रहे हो? जैसे मैं बताता हूँ what I mean by pattern. So what
सर
pattern I
ये इसमें
observe?
कौन
अब बेटा मैं कुछ गलत लिख रहा हूँ?
नहीं नहीं सर, सही लिख रहे होंगे. मैं बता रहा था सर, क्वांटम मैकेनिक्स में हाइड्रोजन एटम में भी आता है ये स्फेरिकल
हाँ, एग्जैक्टली
हार्मोनिक्स.
एग्जैक्टली. इसलिए मैं कह रहा हूँ कि आज अभी मेहनत कर लोगे तो एटलीस्ट हाइड्रोजन एटम में लाइफ इजी रहेगी तुम्हारी. समझ रहे हो मेरी बात? सो दैट इज व्हाट आई वांट टू से. सो फॉर एग्जांपल, याद रखने का तरीका क्या हो सकता है कि व्हेनेवर यू आर हैविंग जीरोस, सी हियर जीरोस, सो पहली बात तो e की पावर i टाइम 5 वुड नॉट अकर. एंड देन यू हैव सिंपली लेजेंडस पॉलिनोमियल ओनली. तो 2 होगा तो 3 cos स्क्वायर थीटा माइनस 1 बाय 2 आएगा. एंड फॉरगेट अबाउट ऑल दीस थिंग्स. इवन इफ यू डोंट रिमेंबर इट, हार्डली मैटर्स. ठीक है, हार्डली मैटर्स. एंड फिर है तो सही थोड़ा सा, इफ यू कैन रिमेंबर दिस, यू कैन लाइक 12 plus 1 L minus 1 M2, you can remember this constant if you can, only if you can. Even if you don't, examinations don't like come in a way that they don't ask you this. मतलब usually they hide it in some constant, so I don't believe कि कोई issue होगा. So अगर m equal to 0 है, तुम्हारा कोई दिक्कत है ही नहीं. There will be no term in e की power iota 5, and there will be similarity in legendus, like similarity of the structure, because P1 cos theta is cos theta and P2 cos theta is 3 cos square theta. Problem arises when you have some m term. So whenever you have m term, then just remember that if you are supplied with 1 1, there would be, instead of cos theta, you would have sin theta in power 1. And if it's 2 2, then instead of sin theta, this would be sin square theta. बस ऐसे याद रखो. Otherwise ये तो पता चल ही जाएगा कि m अगर 1 है, then this will be e की power iota m5, and m equal to 2 है तो this will be. So all ये चार तो हो गए solve. These four you can remember. You can remember that this is some constant. And if you have these mixed terms, then remember that instead of cos theta, you'll have sin theta cos theta. So, I mean, I don't know, but this is a certain thing that I remember. But again, I'm saying it is difficult, but if you can do so, it will be easier for me. And why I have not written m equals to minus wale terms? Because I know that yl minus m theta comma phi is simply minus 1 raised to power m yl m theta comma phi. So you don't need to remember, like if you replace 1 by minus 1, all you need to do is just replace it by negative minus 1, like negative 1 here. Is that clear? So I hope this is the generalized solution to Laplace's equation in spherical polar coordinates. This is something that we are going to pursue in a very brief lecture, at least in one lecture, not more than that, tomorrow. Okay, because this particular thing has not been asked, so probably if it is asked, so at least you remember prepared. At least you remember, at least you remain prepared. So I hope to meet you tomorrow. Is that clear?
यस सर.
Okay जी, चलो कल मिलते हैं.
सर थैंक यू.
Okay, thank you.